Hi, welcome to Physical Science 1.3b. Now we're going to look at quantitative comparisons. This will only be comparing walking objects or standing objects. We'll not take into consideration objects that run at this time. So first of all, what if you're given a data table or a graph? That's what we're looking at. So these will actually have numbers in them. When given a data table or a graph, you have to be able to identify each object's location at a given time, calculate the velocity of each object, identify where the objects will meet, and essentially compare the motion of two objects. So let's get started on some examples. Location questions. If you had to answer this question, where is each object at 4 seconds? Remember that locations are relative. Saying something is 20 meters from where it started is very different than saying something is 20 meters from the origin, unless it started at the origin. So if you look at 4 seconds, object A is 60 meters from the origin, object B is 12 meters from the origin, object C is 34 meters from the origin, and object D is 76 meters from the origin. These are very different than if we compared them to where they started. Object A would only be 20 meters from where it started because it started at 40 meters from the origin. Velocity questions. How fast is each object going? This is just a matter of looking at distance over time, because remember, velocity is distance divided by time. So object A went from 40 to 90. That's 50 in 10 seconds. That's 5 meters per second. Object B went from 20 to 0. That's a negative 20, or a drop of 20 in the same 10 seconds, giving us a velocity of negative 2 meters per second. Object C went from 50 to 10. That's a drop of 40 in 10 seconds, which is negative 4 meters per second. And object D went from 100 to 40, which is a drop of 60 in 10 seconds. So its velocity should be negative 6 meters per second. So looking at the data, which object is traveling in a positive direction? Which object is increasing position? Well, only object A has a positive velocity, so it's the only one that is going in a positive direction. If you were asked the question, where do objects A and C meet? Looking at objects A and C, notice where their numbers are the closest. It's right here between 1 and 2 seconds, or 0 and 2 seconds. So when the numbers are not exact, they're not specific, you have to be general. Objects A and C will meet approximately 45 meters from the origin after 1 second. Because I know that at 1 second, object A is going to be at 45, and object B is going to be about 46. So they're going to meet not at any perfect pretty point, but somewhere in between. So what if you started with a graph? The same questions apply. Where is each object at 5 seconds? Well, this is color-coded, so be very specific. You may want to zoom in. Blue starts 15 meters from the origin, but at 5 seconds, he is 25 meters from the origin. Red starts at 25 meters from the origin, but at 5 seconds, he is 10 meters from the origin. Green, likewise, is 15 meters from the origin, and orange is 6 meters from the origin. Remember that locations are relative. Saying something is 20 meters from where it started is very different than saying it is 20 meters from the origin. So again, what is the velocity of each object? Remember, this is going to require really looking at the graph, find two perfect pretty points, and do the rise over the run. So the red line goes from 25 to 10 in 5 seconds. That's negative 15 divided by 5 is a negative 3 meters per second. The blue line goes from 15 to 25 in 5 seconds. That's 10 divided by 5 is 2 meters per second. The green line goes from 20 to 0 in 20 seconds. That's a drop of 20 in 20 seconds, which is a negative 1 meter per second. Now the orange line or the yellow line is a little more tricky. It starts at 1, but in these 10 seconds, it's at 11. And in 20 seconds, it's at 21. So it again goes 20 meters in 20 seconds. That's a velocity of 1 meter per second. So then which object is going the fastest? Remember that the steeper the line, the faster it is going. Red is the steepest, therefore it has the fastest speed. So where do objects meet? Again, remember to read the graph carefully. So where do red and blue intersect? Well, if you look at red and blue right here, that point of intersection is the point 219, but that's not an acceptable answer in science when you actually have a meaning to location. Saying that they meet 19 meters from the origin at 2 seconds is the correct answer. All right, you're going to be doing more of these problems in class using graphs and tables. Thanks for watching.